There's a photograph from 1972, Apollo 17, the last time humans went to the moon. In that image, Earth hangs in the void, blue, fragile, alone. 50 years later, we still haven't gone back. Not because we forgot how, not because we lost interest, because something changed, and most of us haven't noticed yet. For most of human history, Earth was everything. The ground beneath our feet, the air in our lungs, the sky that protected us from radiation, from vacuum, from the indifference of space. We didn't think of it as temporary because nothing in our experience suggested it should be. Civilizations rose and fell, empires burned, species disappeared, but Earth remained, constant, forgiving, ready to start over. This stability created an assumption so fundamental we rarely question it, that there will always be more time, that Earth will always be here, exactly as it is now, waiting for us to finally get serious about leaving. But stability isn't permanence. It's just a long enough illusion that we mistake it for forever. Every generation believes the future will have better tools, better rockets, better technology, better understanding, so we defer, we wait. We assume the problem of leaving Earth will be easier to solve tomorrow than it is today. And in some ways, that's been true. We went from the first powered flight to landing on the moon in 66 years. From room-sized computers to devices in our pockets in half a century. Progress felt inevitable, exponential. But progress isn't a law of nature. It's a consequence of conditions, stable societies, surplus resources. A planet that supports complex industrial systems without collapsing under the weight of them. Those conditions aren't guaranteed, and they may not last as long as we think. Most people know about asteroids, solar flares, supervolcanoes. These are the dramatic risks, the ones that make headlines. But they're not the ones that matter most. The threats that actually constrain our future aren't sudden. They're gradual, patient, unavoidable. The sun, for instance. Right now, it's stable, predictable, life-giving, but it's also aging. Every 100 million years, the sun's luminosity increases by about 1%. That doesn't sound like much, but over geological timescales, it compounds. In 500 million years, maybe less, Earth's oceans will begin to evaporate. The greenhouse effect will spiral out of control. Complex life will become impossible. 500 million years sounds distant, almost abstract. But consider this. Complex life on Earth has existed for roughly 600 million years. We're already closer to the end of Earth's habitability than we are to the beginning of multicellular life. The window was never as wide as we thought. Then there are the rarer events. Gamma-ray bursts from collapsing stars, nearby supernovae, rogue planets passing through the solar system. Any of these could sterilize Earth's surface without warning. The probability in any given century is low, but over millions of years, the odds shift. And we've only been a technological species for a few thousand. There's also a more subtle problem. Resources. Not just oil or minerals, though those matter, but the accessible, easy-to-extract resources that bootstrapped industrial civilization in the first place. Surface coal, shallow oil deposits, high-grade ores. We've already used most of them. If civilization were to collapse and rebuild, the next society wouldn't have the same starting conditions we did. The low-hanging fruit is gone. They might never reach the technological threshold required to leave the planet. Which means our window isn't just about time, it's about trajectory. We talk about space colonization as if it's inevitable. Mars bases, lunar outposts, generation ships to other stars. We have the vision, we have the equations, we even have some of the hardware, but having the tools doesn't mean we're ready to use them. Because leaving Earth isn't just an engineering problem, it's a biological one. Humans evolved in one gravity, One atmosphere, one magnetic field, one day-night cycle. Our bones, our muscles, our cardiovascular systems, our circadian rhythms, all of it calibrated to Earth. In microgravity, bones lose density, muscles atrophy, fluid shifts toward the head, vision deteriorates. We can mitigate some of this with exercise, with medication, with rotating habitats. But we can't eliminate it, not yet. And that's just microgravity. On Mars, gravity is 38% of Earth's. We don't know if that's enough to prevent long-term degradation. We've never tested it. We don't know if children can develop normally in low gravity. We don't know if pregnancies are viable. We don't know because we've never tried. And trying means sending people on one-way trips to find out. Then there's radiation. Earth's magnetic field shields us from solar wind and cosmic rays. In space, that protection disappears. Mars has no magnetic field. The Moon has none. A spacecraft traveling to another star would pass through a radiation environment we barely understand. Shielding helps, but perfect shielding is heavy, expensive, difficult to maintain. Long-duration space travel means accepting levels of radiation exposure that would be unthinkable on Earth. And beyond the biology, there's logistics. A sustainable colony isn't just a habitat module and a greenhouse, it's manufacturing, medicine, energy, spare parts, social stability. It's a complete industrial base, transported across millions of kilometers, operating in an environment where a single failure can kill everyone. We've never done anything close to this. Not in Antarctica. Not on oil rigs. Not in submarines. Those environments are hostile, yes, but they're still on Earth. Help is always a few days away. In space, help doesn't exist. There's a concept in astrobiology called the Great Filter. The idea is that there's some barrier between simple life and spacefaring civilization that very few species cross. We don't know what the filter is. Maybe it's the origin of life itself. Maybe it's the development of intelligence. Maybe it's the transition to multicellularity. Or maybe the filter is ahead of us. Maybe most civilizations destroy themselves before they leave their home planet. Or maybe they simply lose the capacity to do so. Not through war or disaster, but through drift. Through the slow erosion of the conditions that make space exploration possible. Because leaving Earth requires an enormous, sustained effort. It requires surplus resources, political stability, long-term thinking, a collective belief that the future matters. It requires a civilization at the peak of its capability. And that peak may not last as long as we assume. History is full of societies that built extraordinary things and then forgot how. The Romans had concrete that could set underwater. The recipe was lost for 1,000 years. The Greeks had mechanical computers, the Antikythera mechanism. Nothing like it appeared again for centuries. Knowledge isn't permanent. Infrastructure isn't permanent. The conditions that allow for space travel aren't permanent. If we wait too long, the window doesn't just narrow, it closes. And once it closes, it may never open again. Imagine a future where humanity never leaves Earth. Not because we chose to stay, but because we missed the moment when leaving was possible. The rockets stop launching. The space stations are abandoned. The plans for Mars are filed away and forgotten. Life goes on. Civilizations rise and fall. Cultures evolve. People are born, live, and die. For a while, maybe a long while, it doesn't seem to matter, but the universe continues. The sun keeps aging. The asteroid orbits keep shifting. The cosmic threats keep accumulating. And Earth, despite its resilience, isn't infinite. Eventually, something happens. Maybe it's gradual. The slow warming of the sun making Earth uninhabitable over millennia. Maybe it's sudden, an impact we didn't see coming. Either way, the result is the same. Humanity, After millions of years of evolution, after building art and music and mathematics and meaning, disappears. Not because we weren't intelligent enough, not because we didn't see it coming, but because we assumed there would always be more time. There's no countdown clock, no alarm that will tell us when the window is about to close. We won't know until it's already too late. But there are signs. The complexity required to launch anything into space. The difficulty of maintaining long-term projects across generations. The fragility of the systems we depend on. These aren't problems that solve themselves. They require intention, foresight, a willingness to act before the crisis becomes obvious. Because by the time the crisis is obvious, the capacity to respond may already be gone. Leaving Earth isn't about fear. It's not about running away from problems or chasing fantasies. It's about recognizing that this planet, however beautiful, however nurturing, was never meant to be our final destination. It's about understanding that life, real life, doesn't just survive. It reaches. It explores. It spreads beyond the boundaries of where it began. Not because it has to, but because that's what life does. And if we forget that, if we decide that Earth is enough, that staying is easier than leaving, we won't just be choosing our own fate. We'll be choosing the fate of every generation that comes after us. Every discovery they'll never make. Every world they'll never see. Every version of humanity that will never exist. Because we ran out of time. Not all at once, but slowly, quietly, without noticing. The universe doesn't rush, but it also doesn't wait.